And now, in this lecture, we will answer on two questions. In the first question, we'll find out the area of the blue shape, and in the second question, we'll find out the radius of this circle that blocks triangle ABC. So we start with the first question. In the first question, we have in the drawing a circle that blocks triangle ABC. We know that AB, side AB is the diameter of the big circle, and also triangle ABC blocks the small circle, or the small circle is inscribed by triangle ABC, and the radius of the small circle equals to 4 units, while the radius of the big circle equals to 13 units. And we want to find out the area of the blue shape. Okay, so first of all, we define the center of the small circle as O. And we also define the point of tendency of tangent CB with the small circle Sn. We will define the point of tendency of tangent AC with the small circle Sn. And we will define the point of tendency of tangent AB with the small circle SL. And I present you the first rule. According to the first rule, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Again, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Here we'll join points O and M together by a straight line. So O is the center of the small circle, M is a point of the small circle itself, and this is exactly the definition of a radius. So OM is the radius of the small circle, so we define the radius of the small circle as small r, and it is given in the question the small r equals to 4 units. In the next step, we join points O and N together by a straight line. Point O is the center of the small circle, point N is the point on the small circle itself. That is to say, ON is the radius of the small circle that is equal to 4 units. So here we have the radius OM, that is 1 to the point of tendency, that is to say the radius OM, it is 1 to point M, that is the point of tendency of tangent CB with the small circle. And whenever you have a radius that is 1 to the point of tendency, then tangent CB will be perpendicular to the radius MO. So CB is perpendicular to MO, that is to say this angle equals to 90 degrees according to number 1, and this angle also equals to 90 degrees. Likewise, we have the radius ON, that is 1 to the point of tendency, that is to say it is 1 to point N, that is the point of tendency of tangent AC with the small circle. And whenever we have a radius that is 1 to the point of tendency, then tangent AC will be perpendicular to the radius NO. So AC is perpendicular to NO, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. In addition, we have the rule that any peripheral angle that rests on the diameter of a circle must be equal to 90 degrees. So here we have peripheral angle ACB. Peripheral angle ACB rests on side AB, that is the diameter of the big circle. Therefore, peripheral angle ACB equals to 90 degrees, according to the rule that I mentioned, that any peripheral angle that rests to the diameter of a circle equals to 90 degrees. So actually, in quadrilateral ONCM, in this quadrilateral we have 1, 2, 3 right angles. Okay, repeat again. In quadrilateral ONCM, we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle MON. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay? So here we subtract from this equation 270 degrees, and we get that the missing angle MON equals to 360 degrees on 270 degrees. It is equal to 90 degrees. So this angle MON equals to 90 degrees. So actually, if we know that inside quadrilateral ONCM, all of its angles, we have 4 right angles. Inside quadrilateral ONCM, we have 4 right angles. All the angles of quadrilateral ONCM are right angles. And we know that any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate the quadrilateral ONCM as a rectangle. Okay, quadrilateral ONCM is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other, so the opposite sides of a rectangle ONCM, they are equal to each other. That is to say, ON equals to CM. ON equals to CM according to the rule that the opposite sides of a rectangle are equal to each other. ON equals to CM. But we have already found out that ON equals to 4 units. It is the radius of the small circle. So we can write here that ON equals to 4 units, and from this equation 4 equals to ON equals to CM. We derive that CM is also equals to 4 units. CM equals to 4 units. So we can write down here that CM equals to 4 units. Likewise, according to the rule that the opposite sides of orthogonal and equal to each other, we get that OM equals to NC. OM equals to NC. OM equals to NC. According to the rule of the opposite sides of orthogonal and equal to each other. But we have already found out that OM equals to 4 units. OM equals to 4 units. It is the radius of the small circle. So we can write here that OM equals to 4 units. And to write this equation, 4 equals to OM equals to NC, we will derive that NC is also equals to 4 units. NC equals to 4 units. NC equals to 4 units. Okay. In the next step, we will define side AC of triangle ABC as A. Here, AC equals to A according to our definition. AC equals to A. We define side CB as B. CB equals to B also according to our definition. And we define side AB, the diameter of the big circle, as C. AB equals to C according to our definition. I repeat again. AC equals to A, AB, CB equals to B, and AB equals to C, according to our definition. So, what is the length of line segment AM? The length of line segment AM. From the drawing, it is very easy to see that AM equals to AC minus MC. AC minus MC. So AM equals to AC, that is A according to our definition, minus CM, that is 4 according to what we have already found out. So in conclusion, we found out that AM equals to A minus 4. So we can write down here that AM equals to A minus 4. Likewise, we find out the length of line segment MB. MB from the drawing, it is very easy to see that MB equals to CB minus CM. I repeat again, MB equals to CB minus CM. So MB equals to CB, that is B, according to our definition, minus Cm, that is equal to 4, according to what we have already found out. So in conclusion, we found out that MB equals to B minus 4. MB equals to B minus 4. So in conclusion, we found out that MB equals to B minus 4 and AM equals to A minus 4. In the next step, I present to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. I repeat again, the lengths of two tangents from a common external point to a circle are equal. So here we will focus on the common external point, point A, this point, and from the common external point, point A, we have two tangents to the small circle. We have tangent AL, and we also have tangent AM. According to rule number 2, the lengths of those two tangents are equal to each other. That is to say, AL equals to AM according to rule number 2. So AM equals to AM according to rule number 2, but we've already found out that AM equals to A minus 4. So we can write here that AM equals to A minus 4. And from this equation, AN equals to AM equals to A minus 4, we will derive that AN is also equals to A minus 4. AN, so AN is also equals to A minus 4. In the next step, we will focus on the common external point, point B. From the common external point, point B, we have two tangents to the small circle. The first tangent is BL and the second tangent is BM, and according to rule number 2, they are equal to each other. That is to say, BL equals to BM according to rule number 2. So BL equals to BM, but we have only found out that BM or MB equals to B minus 4. So we can write here that BM equals to B minus 4. And from this equation, BN equals to BM equals to B minus 4, we will derive that BN is also equals to B minus 4. So further, that BN is also equals to B minus 4. So actually, in conclusion, we found out that BL equals to B minus 4 and AL equals to A minus 4. Okay? And we know that AB is the diameter of the big circle, any diameter of a circle is twice as long as the radius. So if we define the radius of the big circle as capital R, then AB must be equal to 2 times capital R. But it is given us the question that R, the radius of the big circle, is equal to 13 units. So 2 times 13 is 26, that is the diameter AB of the big circle. So actually, from one side, the diameter AB of the big circle is equal to 36 units. But from the other side, from the drawing, we can see that AB equals to AL plus LB. Okay. AB equals to AL plus LB from it is called from the drawing. So actually we can find out that according to equation number 1, the diameter that is equal to 26 units equals to AL. AL is A minus 4 plus LB, this is B minus 4. Okay, so in conclusion, we found out that the diameter of the circle is equal to 26 units, is equal to A minus 4 plus B minus 4. So 26 equals to A plus B, minus 4 plus minus 4 is minus 8. So here we will add to this equation number 1, 8, and we get that according to equation number 1, 26 plus 8 is 34, so 34 equals to A plus B according to equation number 1. Okay. So here we will first multiply, we will square equation number 1, or we will square both sides of equation number 1, and we will get that according to equation number 1, A plus B square equals to 34 square. Here we will open the brackets on both sides of this equation, equation number 1, and we will get that according to equation number 1, A plus B square equals to A square plus B square plus 2 times AB, and it is equal to 34 squared, that is 1156. Okay. According to equation number 1, A plus A squared plus B squared plus 2 times AB equals to 1156. Okay. In the next step, we focus on the right triangle, triangle ABC. on the right triangle, triangle ABC by PT is the version for Pythagoras theorem. So according to the Pythagoras theorem, in the right triangle, triangle ABC, we get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, therefore the square of the hypotenuse is AB squared. That is equal to the sum of the squares of the perpendiculars, that is to say, it is equal to AC squared plus CB squared. So I'll repeat again, in the right triangle, triangle ABC, according to the Pythagoras theorem, AB squared equals to AC squared plus CB squared. We have already found out that AB equals to 26 units, so AB squared is 26 squared, that is 676, and it is equal to AC squared. AC equals to A according to our definition, so A squared is A squared plus CB squared. CB equals to B according to our definition, so CB squared will be equal to B squared. So actually, in conclusion, we found out that according to equation number 2, A squared plus B squared equals to 676. So, and because of the fact that A squared plus B squared equals to 676, it means that we can substitute A squared plus B squared in this equation, equation number 1, by 676. So we do it now, and we get that according to equation number 1, A squared plus B squared, that is 676, plus 2 times AB equals to 1156. Okay. So here we subtract 676 from this equation, equation number 1, and we get that according to equation number 1, 2 times AB equals to 1156 minus 776, and 1156 minus 676 equals to 480. Okay, so from now to go into equation number 1, 2 times AB equals to 480. Here we divide this equation, equation number 1 by 2, and we get that according to equation number 1, A times B equals to 480 over 2 is 240. So here we divide again equation number 1 by 2, and we get that according to equation number 1, AB over 2 equals to 240 over 2 is 120. So if I know that according to equation number 1, AB over 2 equals to 120. Okay. But what is actually the area of the blue shape? From the drawing, it is very easy to see that the area of the blue shape equals to the area of triangle ABC I repeat again, the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. Repeat again, the area of the blue shape, from the drawing it is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. So the area of triangle ABC is equal to the base of the triangle that is AC minus the height to the base that is CB over 2. Repeat again. The area of triangle ABC equals to AC times CB over 2 minus the area of the small circle. The area of the small circle equals to pi r square when r equals to the radius of the small circle. So the area of triangle ABC equals to AC is A according to our definition, CB is B according to our definition, over 2. So in conclusion, found out that the area of triangle ABC equals to AB over 2, A times B over 2, minus the area of the circle that is pi r square when r equals to 4 units. So if r equals to 4 units, then r square equals to 4 square, that is 16. So the area of the small circle in total will be equal to 16 pi. Okay, so the area of the blue shape equals to the area of triangle ABC that is AB over 2 minus the area of the small circle that is 16 pi. But we already found out that AB over 2 equals to 120, so we can substitute AB over 2 by 120, and we also have to subtract from it the area of the small circle that is 16 pi. So in conclusion, we found out that the area of the blue shape equals to either 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. I repeat again, the area of the blue shape equals to either 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. So we finished with the first question. In the next step, I will present you the second question, and we will solve the second question in 3 different methods. So in the drawing, we have this circle. Inside the circle, we have triangle ABC that is inscribed by the circle. We know that the area of triangle ABC equals to 9 square units. Is given as the question. And we also know that side AB of triangle ABC equals to 5 units. Side AB equals to 5 units. Side BC of triangle ABC equals to 6 units. And we want to find out the area of this, and we want to find out the radius of this circle that blocks triangle ABC. So we start with the first method. In the first method, from point A, we will draw a perpendicular on BC. So actually here, this angle equals to 90 degrees, and this angle will also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as D. So we actually know that the area of triangle ABC equals to 9 square units. So we can write down here that the area of triangle ABC equals to 9 square units. Actually, the area of triangle ABC equals to the base of the triangle that is BC times the height to the base that is AD over 2. I repeat again, the area of triangle ABC equals to the base of the triangle that is BC times the height to the base that is AD over 2. But it is given us the question that BC equals to 6 units, so we substitute BC by 6, so it is 6 times AD over 2. So here comes to question number 1. 9 equals to 6 over 2 is 3, so 9 equals to 3 AD. Here we divide this equation number 1 by 3, and we get that according to equation number 1, AD equals to 3 units. Okay, AD equals to 3 units. You can write here that AD equals to 3 units. In the next step, we'll focus on the right triangle, triangle ABD. On the right triangle, triangle ABD, by PT is a relation from Pythagoras theorem. So in the right triangle ABD, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In this right triangle, triangle ABD, the hypotenuse is AB, so the square of the hypotenuse is AB squared, and it is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to AD squared plus BD square. Repeat again, in the right triangle, triangle ABD, according to the Pythagoras theorem, we get this AB square equals to AD square plus BD square. So here, according to question number 2, AB equals to 5, so AB square is 5 square, that is 25, and it is equal to AD square. AD is 3, so AD square is 3 square, that is 9, plus BD square. Okay, so here 25 equals to 9 plus BD square. Here we will subtract 9 from this equation, equation number 2, and we find out that according to equation number 2, 25 minus 9 is 16, so 16 equals to BD square, according to equation number 2. Here we will take out all of this equation, equation number 2, and we get that BD equals to the square root of 16, that is 4 units. BD equals to 4 units. So we can write down here that BD equals to 4 units. So what is the length of side CD? From the drawings it's very easy to see that the length of side CD equals to BC minus BD. So CD equals to BC minus BD. I repeat again, CD equals to BC minus BD. So CD equals to BC is 6 units, minus BD is 4 units. So CD equals to 6 minus 4, that is 2. CD equals to 2 units. Can write down here that CD equals to 2 units. In the next step we focus on the right triangle, triangle ADC. So in the right triangle, triangle ADC, according to the Pythagoras theorem, so in the right triangle, triangle ADC, according to the Pythagoras theorem, I repeat again, in the right triangle, triangle ADC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, so the square of the hypotenuse is AC square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AD square plus DC square. Okay, we found out that AC square equals to AD square. AD equals to 3, so AD square is 3 squared, that is 9, plus DC square. DC equals to 2, so DC square is 2 squared, that is 4. So in conclusion, we found out that AC square equals to 9 plus 4, that is 13. AC square equals to 13 units. Here we take out of this equation, and we get that AC equals to the square root of 13 units. So here we found out that AC equals to the square root of 13 units. In the next step, we will define the center of this circle as O, and we will join points A and O together by a straight line. Then we will extend side AO until it touches the circle at this point. We will define the touching point of the extended AO in the circle as point E. So here AE is the diameter of the circle. Why? Because of the fact that point AE passes through the center of the circle. AE is the diameter of the circle. In the next step, we'll join points E and B together by a straight line. So here we created the peripheral angle ABE, and the peripheral angle ABE rests on AE, that is the diameter of the circle. Therefore, peripheral angle ABE equals to 90 degrees according to the rule that any peripheral angle that rests on the diameter of the circle is equal to 90 degrees. So this angle equals to 90 degrees. According to the rule that any peripheral angle that rests on the diameter of the circle is equal to 90 degrees. Okay, so angle ABE equals to 90 degrees according to the rule that I mentioned. And we also have a second rule that states that if two peripheral angles rest on the same chord, they are equal to each other. Okay, peripheral angles that rest on the same chord, they are equal to each other. If you focus on chord AB, then on chord AB we have two peripheral angles that rest on chord AB. The peripheral angle, the first peripheral angle is angle AEB, and the second peripheral angle is angle ACB. Angle ACB. Repeat again. Angle AB equals to angle ACB, according to the rule that if two peripheral angles are raised to the same chord, they are equal to each other. So angle AB equals to angle ACB. So if we define angle ACB as theta, here angle ACB equals to theta, then from this equation angle AB equals to angle ACB equals to theta, we will get that angle AB is also equals to theta. So this angle AB equals to theta. So if you focus on the right angle triangle ABE, we know that angle AB equals to theta, angle ABE equals to 90 degrees, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in triangle ABC to 180 degrees. This angle must be equal to 90 degrees minus theta. Okay. For the same reason, exactly for the same reason, angle DAC also must be equal to 90 degrees minus theta. So in the next step, we will prove that the right triangle AB is similar to the right triangle ADC. So why those two right green triangles are similar to each other? So write it down. Repeat again, we prove that the right green triangle AB is similar to the right green triangle ADC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So here we have angle ABE is equal to this angle ADC, and they are both equal to 90 degrees. Okay, so yeah, angle AB equals to angle ADC, they are both equal to 90 degrees, therefore they are equal to each other. In addition, we have those two angles are both equal to theta, therefore they are equal to each other. So angle AEB, this angle So angle ABE equals to angle ACD, and the above equal to theta, therefore they are equal to each other. Repeat again. Angle AEB equals to angle ACD, and the above equal to theta, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees to minus theta, therefore they are equal to each other. So this angle, that is angle BAE, equals to this angle that is actually angle DAC. Angle BAC equals to angle BAE, this angle equals to angle DAC, this angle, and they're both equal to 90 degrees minus theta, therefore they're equal to each other. Repeat again, angle BAE equals to angle DAC, and they're both equal to 90 degrees minus theta, therefore they're equal to each other. So we prove that all the angles from triangle ABE can go into all the angles from triangle ADC. Therefore, triangle ABE is similar. This is the sum of similar to triangle ADC, according to angle similarity rule. Yeah, only so angle similarity rule. And from the fact that the two grand triangles are similar to each other, we'll conclude that AB over AD equals to AE over AC. Repeat again. From the fact that the two grand triangles are similar to each other, we conclude that AB over AD equals to AE over AC. Here AB is 5, AD is 3, AE is 2 out, is the diameter of the circle. AE equals to 2 times capital R, that is the diameter of the circle, and AC equals to the square root of 13 units. Okay. So in conclusion, we found out that according to question number 3, 3 over 5 over 3 equals to 2R over square root of 13. Here we'll multiply this equation by square root of 13, and we'll get that according to equation number 3, 5 times square root of 13 over 3 equals to 2r. Here we will divide this equation number 3 by 2, and we get that according to equation number 3, the radius of the circle that we are looking for, it is equal to either 5 over 6 times square root of 13 units, or in terms of numbers, it is a little bit greater than 3 units. Okay. Here, the radius of this circle that belongs to ABC equals to either 5 times square root of 13 over 6 units, or in terms of numbers, it is a little bit greater than 3 units. So we finish with the first method. In the next step, I'll present to you how to find out the radius of this circle according to the second method. In the second method, we found the things that we have already found out. Use all the things that we have already found out in the first method. So here from point A we know perpendicular on BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the dotted point of the perpendicular from point A and BC as D. We have already found out in the first method that DC equals to 2 units, AD equals to 3 units, and BD equals to 4 units. In the next step, we will extend line segment AD by a straight line until it touches the circle at this point, point A. AD is perpendicular from point A on BC. Therefore, it is absolutely a straight line. Then, when we extended the straight line AD by straight line, we got AE, and when we extend the straight line by straight line, the result must be a straight line. So AE is a straight line. So if you focus on this side of the straight line AE, it's point D, then the sum of the angles must be equal to 180 degrees. So 90 degrees plus this angle CDE, in total they must be equal to 180 degrees. So we subtract 90 degrees from the equation, and we found out that the missing angle, this angle CDE, is also equal to 90 degrees. And the same thing is true on the other side of the straight line AE. If you focus on this side of the straight line AE at point D, then the sum of the angles here must be equal to 180 degrees. So this angle that is 90 degrees plus this angle that is actually angle BDE, in total they must be equal to 180 degrees. We subtract 90 degrees from the equation, and we found out that the missing angle is also equal to 90 degrees. So all the angles around point D are right angles. Okay. So in the next step, I will present to you one number 1. So actually, if we have this circle, actually have here called AB. This is called AB. that intersects with chord CD. This is chord CD. It's point O. Point O is the intersection point of chord AB with chord CD. Okay? So if this is the data that has been given to us, then the following equation is true. It's AO times OB equals to CO times OD. Okay, I repeat again, if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. You can implement rule number 1 in number drawing. Why? Because in number drawing we have this circle, and inside this circle we have chord AE that intersects with chord BC at point D. Therefore, according to rule number 1, we get that BD times DC must be equal to AD times DE. So this again, BD times DC equals to AD times DE. So here, BD equals to 4, DC equals to 2, and it is equal to AD is 3 times DE is the missing 9 segments. So in conclusion, we found out that 4 times 2, that is 8, it is equal to 3 times DE. Here we divide this equation by 3 and we get that DE equals to 8 over 3. DE equals to 8 over 3 units. Here DE equals to 8 over 3 units. In the next step, I present to you new rule number 2, according to rule number 2. So if we have this circle, we have chord AB, this is chord AB, that intersects with chord CD, this is chord CD, so they intersect with each other at 90 degrees. The intersection point, they create 90 degrees between them. define the intersection point between chord AB and chord CD as O. The length of line segment AO is A. The length of line segment OB is B. The length of line segment CO is C. And the length of line segment OD is D. Then according, so if chord AB intersects with chord CD at 90 degrees, then according to rule number 2, we get that 4 times R square equals to A square plus B square plus C square plus D square. We can implement rule number 2 in our drawing, because in our drawing we have chord BC that intersects with chord AE at 90 degrees. Therefore, according to rule number 2, we get that 4 times R square. R is the radius of the circle that contains the two chords, equals to BD square plus DC square plus AD square plus AD square plus DE square. Actually, this equation is the implementation of rule number 2 in our drawing. So we get that 4 times R square equals to here BD square. BD is 4, so BD square is 4 squared, that is 16, plus DC square. DC is 2, so DC square is 2 squared, that is 4, plus AD square. AD is 3, so AD square is 3 squared, that is 9, plus DE square. DE is 8 over 3, so DE square is 8 over 3 squared, that's is to say 8 squared is 64 over 3 squared, that is 9. So we found out that 4 times R square equals to 16 plus 4 is 20, and 20 plus 9 is 29, so it is 29 plus 64 over 9. Here we multiply 29 by 9 and then we divide it by 9 in order to have a common factor with this expression. So 29 times 9 is 261 plus 64 over 9. 261 plus 64 is 325 over 9. So in conclusion, we found out that 4R square equals to 325 over 9. Here we divide this equation by 4 and we get that R square equals to 325 over 9 times 4 is 56. So R square equals to 25 times 13, times 13 is 325, so it is 25 times 14 over 36. Here we take out all of this equation and we get that R, the radius of the circle that we are looking for, it is equal to the square root of 5, the square root of 25 is 5 and the square root of 36 is 6, so it is 5 over 6 times square root of 13 units. In terms of numbers, it is a little bit better than 3 units. Okay. So I actually finished with the second method. In the next step I present to you how to find out the radius of this circle according to the third method. In the first method, we define angle ABC as theta. And here we have if we have triangle ABC, that will be any triangle this is triangle ABC. Side AB equals to A units in length, side AC equals to B units in length, and the angle here is theta. Again, the angle between side AB and side AC is theta. Then, according to the new formula, the area of this triangle, triangle ABC, will be equal to A times B times sinus theta over 2. A times B times sinus theta over 2. So the area of this triangle, triangle ABC equals to A times B times sinus theta over 2. We use this formula in order to calculate the area of our triangle, triangle ABC. So the area of triangle ABC equals to 9 square units, and according to the new formula, it will be equal to AB times BC times sinus theta over 2. Okay. So here 9 equals to AB in our triangle, AB is 5 units, BC is 6 units, times sinus theta over 2. So here 9 equals to 5 times 6 is 30, and 30 over 2 is 15. So 9 equals to 15 times sinus theta. So in conclusion, we found out that according to equation number 1, 9 equals to 15 sinus theta. Here we divide this equation number 1 by 3, and we'll get that 15 over 3 is 5, so 5 times sinus theta equals to 9 over 3 is 3. Here we divide this equation number 1 by 5, and you will get that sinus theta equals to 3/5. A sinus theta equals to 3/5. Okay, so we actually found out that sinus theta equals to 3/5. We actually have the trigonometric identity that cosine theta equals to the square root of 1 minus sinus square theta. So cosine theta equals to the square root of 1 minus sinus square theta. We know that sinus theta equals to 3/5, therefore sinus square theta will be equal to 3/5 squared, that is 9/25. So here we multiply 1 by 25 and then we divide it by 25 in order to become a factor of this expression. And we get cosine theta equals to 25 minus 9/25. This is to say cosine theta equals to the square root of 25 minus 9 is 16, so it is 16/25. So we found out that cosine theta equals to the square root of 16/25. So in conclusion, we actually found out that cosine theta equals to the square root of 16 is 4, or the square root of 25 is 5. So in conclusion, found out that cosine theta equals to 4/5. In the next step, we will implement the law of cosines in our triangle ABC. So we present the law of cosines shortly. What I already explained about the law of cosines, so we'll do it shortly. So what is the law of cosines? Actually, if we have triangle ABC, that could be any triangle. This is triangle ABC. The angle between side AB and side AC is theta. Side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. Then according to the law of cosines, we get that cosine theta equals to A square plus B square minus C square over 2 times AB. Okay, so this is the law of cosines. We will implement the law of cosines in our triangle ABC. According to the law of cosines, in triangle ABC, we get that cosine theta equals to AB squared plus BC squared minus AC squared over 2 times over 2 times AB times BC. Okay. We've already found out that cosine theta equals to 4/5, and it is equal to AB squared. AB is 5, so AB squared is 5 squared, that is 25, plus BC squared. BC is 6, so BC squared is 6 squared, that is 36. Minus AC squared. Okay, so this is 25 plus 36 minus AC squared over 2 times AB is 5 and BC is 6. So here we get that 4/5 equals to 25 plus 36 is 61 minus AC squared over 5 times 6 is 30 and 30 times 2 is 60. Here we multiply this equation by 60. We multiply this equation by 60 and we get that 60 over 5 is 12 and 12 times 4 is 48. 48 equals to 61 minus AC squared. Here we will add to this equation AC squared and we will subtract 48 and we get that AC squared equals to 61 minus 48 is 13. Here we take out all of this equation and we get that AC equals to the square root of 13 units. So from there that AC equals to the square root of 14 units. So right here that AC equals to the square root of 14 units. In the next step, I present to you a new formula that calculates the radius of any circle that blocks a triangle. So the radius of the circle that blocks a triangle, that is to say capital R, it will be equal to the multiplication of the sides of the triangle by each other. In this case, it is AB times AC times BC. repeat again, the radius of the circle that blocks a triangle equal to the multiplication of the sides of the triangle by each other, or, by 4 times the area of the triangle that the circle blocks. In this, in our case, it is triangle ABC. So the radius of our circle that blocks triangle ABC, according to the new formula, will be equal to AB is 5 times AC is equal to 13 times BC is 6 over 4 times the area of triangle ABC. And we know that the area of triangle ABC equals to 9 square units. So in conclusion, found out that the radius of the circle the blocks triangle ABC equals to 5 times 6, that is 30, times square root of 13, over 4 times 9, that is 36. So the radius of the circle that blocks triangle ABC will be equal to R. Here we divide both the numerator and the denominator on this side of the equation by 6, and we get that 30 over 6 is 5 times square root of 13 over 36 over 6 is 6. So in conclusion, I found out that the radius of this circle that blocks triangle ABC equals to 5 times square root of 13 over 6 units. So in terms of numbers, it is equal to 3.00 units. It is a little bit greater than 3 units. So we finish with the third method. In the next step, we will summarize the lecture. We start with the first question. In the first question, we have a circle that blocks triangle ABC, and triangle ABC itself blocks the small circle. The radius of the big circle equals to 4 units, and the radius of the big circle equals to 14 units. The radius of the small circle equals to 4 units, and the diameter of the big circle is AB, and we want to find out the area of the blue shape. Okay, so first of all, we define the center of the small circle as O. We define the point of tendency B with the small circle as M. We define the point of tendency of tangent AC with the small circle as M, and when we define this, the point of tendency of tangent AB with the small circle as L. We join points O and M together by a straight line, and we also join points O and N together by a straight line. Here O is the center of the small circle, M is the point of the small circle itself, therefore OM is the radius of the small circle that is equal to 4 units. For the same reason, OM it is also the radius of the small circle that is equal to 4 units. So here we have rule number 1, that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius OM that is drawn to the point of tendency, and whenever we have a radius that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius MO. So CB is perpendicular to MO. That is to say, this angle equals 90 degrees, and this angle also equals to 90 degrees according to rule number 1. And the same thing is true here. We have the radius ON, it is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency of tangent HC with a small circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NO. So AC is perpendicular to NO, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. And here, peripheral angle ACB rests on the diameter of the big circle, therefore it is equal to 90 degrees. So actually quadrangle ONCM, we have 1, 2 right angles. Okay. In quadrangle ONCM, we have 3 right angles, and the sum of 3 right angles is 90 times 3, 270 degrees, plus the size of the 4 angle is the actual angle MON. Total, the sum of those 4 angles must be equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle MON, this angle, is equal to 90 degrees. So in quadrangle MOCN, we have 4 right angles. And then in quadrangle, the first 4 right angles must be at least a rectangle, if not a square. So we relate to quadrangle ONCM as a rectangle. But we know that the opposite sides of a rectangle are equal to each other, that is to say, NO equals to CM. NO equals to CM. But we have already found out that NO equals to 4 units, it is the radius of the small circle. So from this equation, we get that from this equation 4 equals to ON equals to CM, we derive that CM is also equals to 4 units. You know, CM is also equals to 4 units. Likewise, OM must be equal to MC according to the rule that the opposite sides of a rectangle are equal to each other. OM equals to NC, but we have already found out that OM equals to 4 units. So from this equation 4 equals to OM equals to NC, we derive that NC is also equals to 4 units. So therefore quadrangle NCM, it is not a rectangle but a square. Then we defined AC as A, CB as B, and AB as C. What is the length of line segment AM? The length of line segment AM, here it is equal to AC minus MC. AC equals to A, MC equals to 4, so in conclusion AM equals to A minus 4. Then we found out the length of line segment MB. What is the length of line segment MB? MB equals to CB minus CM. MB equals to CB minus CM. CB equals to B and CM equals to 4, so in conclusion we found out that MB equals to B minus 4. Then I presented to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. So if you focus on the common external point A, from point A we have two tangents through the small circle, tangent AL and tangent AL. And according to rule number 2, the lengths of those two tangents are equal to each other, that is to say AL equals to AM. According to rule number 2. But we have already found out that AM equals to A minus 4. So we can write here that AM equals to A minus 4, and for this equation AM equals to A minus 4, we derive that AL is also equals to A minus 4. Yeah, AM equals to A minus 4. Likewise, if we focus on the common external point B, from the common external point B, we have two tangents to the small circle, tangent BL and tangent BM. Tangent BL and tangent BM, and the one in rule number 2, the lengths of those two tangents are equal to each other, that is to say BL equals to BM. According to rule number 2. But we have already found out that BM equals to B minus 4. So from this equation, BL equals to BM equals to B minus 4, we will derive that BL is also equals to B minus 4. BL is also equals to B minus 4. Okay. Then we know that AB is the diameter of the big circle, and the diameter of any circle is twice as long as the radius, so if the radius of the big circle is capital R, then the diameter must be equal to 2 times capital R. But it is given us the question that capital R, the radius of the big circle, equals to 13 units, therefore the diameter must be equal to 2 times 13, that is 26 units. So the diameter AB equals to 26 units from one side, but from the other side the diameter AB also equals to AL plus LB. The diameter AB also equals to AL plus LB, AL equals to A minus 4, LB equals to B minus 4. So in conclusion, found out that the diameter AB that is equal to 26 units equals to A plus B minus 4. We added 8 to this equation and found out that 26 plus 8 is 34, so 34 equals to A plus B. 34 equals to A plus B. We squared both sides of this equation, equation number 1, and found out that A plus B squared equals to 34 squared. A plus B squared is A squared plus B squared plus 2 times AB, and is equal to 34 squared, that is 1156. Then we focus on the right triangle ABC. On the right triangle ABC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. This is to say AB squared equals to AC squared plus CB squared. AB squared equals to AC squared plus CB squared. AB equals to 26, so AB squared is 26 squared, that is 676. And AC equals to A, so AC squared is A squared. BC equals to B, so BC squared is B squared. So in conclusion, found out that 676 equals to A squared plus B squared. And according, so because of the fact that according to equation number 2, A squared plus B squared equals to 676, it means that we can substitute A squared plus B squared in equation number 1 here by 676. We did it when we got that according to equation number 1, A squared plus B squared is 676 plus 2AB equals to 1156. Here we subtracted 676 from this equation, equation number 1, and we got that 2 times AB equals to 480. We divided the equation number 1 by 2 and found out that AB equals to 480 over 2 is 240. We divided the equation number 1 by 2 and found out that AB over 2 equals to 240 over 2 is 120. Okay. So found out that according to equation number 1, AB over 2 equals to 120. And what is the area of the blue shape? The area of the blue shape equals to the area of triangle ABC minus the area of the small circle. That is to say, the area of the blue shape equals to the area of triangle ABC. The area of triangle ABC is equals to the base of the triangle, that is AC, times the height to the base, that is CB over 2. So the area of triangle ABC equals to the base AC times CB over 2, plus the area of the small circle is pi r squared when r equals to 4 units. So we know that AC is A and CB is B, so the area of triangle ABC equals to AB over 2. So the radius of the small circle is r equals to 4, so r squared is 4 squared, that is 16. So the area of the small circle equals to 16 pi. So in conclusion, we found out that the area of the blue shape equals to, here we have AB over 2, but we have only found out that AB over 2 is 120, so we substitute AB over 2 by 120. So in conclusion, the area of the blue shape equals to either 120 minus 16 pi square units, so in terms of numbers it is equal to 69.73 square units. We finish with the first question. Then I presented to you the second question. We approved the second question in 3 different methods. So here we have this circle, and triangle ABC is inscribed by this circle. The area of triangle ABC equals to 9 square units. Side AB of triangle ABC equals to 5 units, and side BC equals to 6 units. And we want to find out the radius of this circle that blocks triangle ABC. So we know that the area of triangle ABC equals to 9 square units. So the area of triangle ABC equals to the base of the triangle that is BC times the height that is AD over 2. BC equals to 6. So here we get that 9 equals to 6 times AD over 2. 6 over 2 is 3. So we found out that 9 equals to 3 times AD. We divided the equation number 1 by 3, and we found out that AD equals to 3 units. Then we implemented the Pythagoras theorem on triangle ABD. According to the Pythagoras theorem on triangle ABD, AB squared equals to AD squared plus BD squared. AB is 5, so AB squared is 25. That is equal to AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus BD squared. We subtracted 9 from this equation number 2, and found out that according to equation number 2, 25 minus 9 is 16, and 16 equals to BD squared. Here we took a root of this equation number 2, and we got that BD equals to the square root of 16, that is 4. So BD equals to 4 units here. BD equals to 4 units. So what is the length of CD? From the drawing it is ready to see that CD equals to CB minus BD. CD equals to BC minus BD. So CD equals to BC, that is 6, minus BD, that is 4. So in conclusion, we found out that CD equals to 6 minus 4, that is 2. Here, so CD equals to 2 units. Then we focus on triangle ABC, we focus on triangle ADC. We implemented the Pythagoras theorem on triangle ADC, and found out that AC equals to square root of 13 units. Then we define the center of this circle as O. We join points A and O together by a straight line. We extended AO by a straight line until it touches the circle at point E. AE is the diameter of the circle because it passes through the center of the circle. We join points A and B together by a straight line. And peripheral angle AEDE rests on the diameter of this circle, therefore it is equal to 90 degrees. And those two angles are equal to each other because they rest on the same chord called AB. So if one angle equals to theta, then the other angle also will be equal to theta. Then we prove that the two green triangles are similar to each other. But first of all, because of the fact that this angle equals to 90 degrees, this angle equals to theta, this angle must be equal to 90 degrees minus theta. The same thing is true in here. Here, this angle must be also equal to 90 degrees minus theta. Then we prove that the two green right triangles are similar to each other. Why they are similar to each other? First of all, we have those two angles that are both equal to 90 degrees minus theta, therefore they are equal to each other. those two angles are both equal to theta, therefore they are equal to each other, and those two angles are both equal to 90 degrees, therefore they are equal to each other. So actually found out that all the angles of triangle ABE can point to all the angles of triangle ADC. Therefore, triangle AB is similar to triangle ADC according to angle similarity rule. And from the fact that the two right triangles are similar to each other, we will conclude that AB over AD equals to AE over AC. AB is 5, AD is 3, AE is 2R, it is the diameter of the circle, and AC is square root of 13. We multiply this equation number 3 by square root of 13, and found out that 2 times r equals to 5 times square root of 13 over 3. We divided this equation number 3 by 2, and found out that the radius of this circle that belongs to triangle ABC equals to either 5 over 6 times square root of 14 units, or in terms of numbers it is a little bit greater than 3 units. We finish with the first method. Then I presented to you how to find out the radius of this circle according the second method. From point A we do perpendicular on BC. So this again equals to 90 degrees, and this again also equals to 90 degrees according to our construction. According to the first method, AD equals to 3 units, DC equals to 2 units, and BD equals to 4 units. Okay, then we extended line segment AD until it touches the circle point E. Then I presented to you rule number 1. According to rule number 1, if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. We can implement rule number 1 in our drawing, because in our drawing we have chord AE that intersects with chord BC at point D. Therefore, according to rule number 1, we get that BD times DC equals to AD times DE. BD times DC equals to AD times DE. BD is 4, DC is 2, AD is 3, and DE is the missing line segment. So we got that 3 equals to 3 times DE. We divided this equation by 3 and found out that DE equals to 8 over 3 units. Here DE equals to 8 over 3 units. Then I presented to you rule number 3, or number 2, according to rule number 2, but before that, all the angles around the point D are right angles according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. Then I presented to you rule number 2. According to rule number 2, if chord AB intersects with chord CD at 90 degrees, then 4r squared equals to a squared plus b squared plus c squared plus d squared. In our drawing we have chord AE that intersects with chord BC at 90 degrees. Therefore, according to rule number 2, we conclude that 4 times r squared equals to BD squared plus DC squared plus AD squared plus DE squared. BD equals to 4, so BD squared is 4 squared, that is 16. DC equals to 2, so DC squared is 2 squared, that is 4. Plus AD squared. AD is 3, so AD squared is 3 squared, that is 9. And we have here plus DE squared. DE is 8 over 3, so DE squared is 64 over 9. So in conclusion, found out that 4r squared equals to 16 plus 4 is 20, and 20 plus 9 is 29. So it is 29 plus 64 over 9. Here we multiplied the 29 by 9, and then we divided it by 9 in order to overcome a fact of this expression, and we found out that 261 plus 64 over 9 equals to 4r squared. 261 plus 64 is 325. So in conclusion, we found out that 4r squared equals to 325 over 9. We divided this equation by 4 and found out that r squared equals to 325 over 4 times 9 is 63. 325 equals to 25 times 14. So we substituted 325 from 25 times 14. And we divided by 36. We took out all of this equation and found out that the radius of this circle that blocks triangle ABC equals to either 5 over 6 times square root of 14 units, so in terms of numbers it is a little bit greater than 3 units. We finish with the third method, then I present it to you how to find out the radius of this circle that blocks triangle ABC according to the third method. In the third method we defined angle ABC as theta. Then I presented to you a new formula if this is triangle ABC, then the area of triangle ABC equals to 8 times b times sinus theta over 2. So according to the new formula, the area of this triangle ABC will be equal to AB times BC times sinus theta over 2. AB is 5, BC is 6 times sinus theta over 2. 5 times 6 is 30, and 30 over 2 is 15. And we know that the area of triangle ABC equals to 9 square units, so in conclusion we found out that 9 equals to 15 times sinus theta. We divided the equation number 1 by 3, and we got that 3 equals to 5 times sinus theta. We divided the equation number 1 by 5 and found out that sinus theta equals to 3/5. And we have that geometric identity that cosine theta equals to the square root of 1 minus sinus square theta. Therefore, cosine theta equals to 1 minus 9 over 25. And here we multiplied the 1 by 25 and then we divided by 25 and we got that cosine theta equals to 25 minus 9 over 25. That is to say, cosine theta equals to 4/5. Cosine theta equals to 4/5. Then we implemented the law of cosines in our triangle ABC. What is the law of cosines? The law of cosines is true in any triangle. So if you have this triangle ABC, that could be any triangle, cosine theta equals to a squared plus b squared plus c squared over 2 times a times b. In our triangle ABC, cosine theta will be equal to ab squared plus bc squared minus ac squared over 2 times ab times bc. Okay? We actually solved this equation and found out that AC equals to the square root of 13 units. Then I presented to you a new formula. According to this new formula, the radius of the circle that blocks triangle ABC will be equal to the multiplication of the sides of the triangle over 4 times the area of the triangle that is blocked by by the circle. So the multiplication of the sides is AB times AC times BC over 4 times the area of triangle ABC, and the area of triangle ABC is 9. So it is AB is 5, AC is square root of 13, and BC is 6, and 4 times the area of triangle ABC, and the area of triangle ABC is 9 square units. So if we put the data inside here, 5 times 6 is 30, so it is 30 times square root of 13 over 4 times 9 is 36. We divided both the numerator and the denominator by 6 and we got that the radius of this circle equals to either 5 over 6 times square root of 13 units or it is a little bit greater than 3 units. Okay, thank you very much.